Well, hi there, boys and girls. Today we're going to talk about Taylor polynomials some more and approximations. It's our second day on this topic, and we've already learned how to write a Taylor polynomial about some center C. And we've got this pattern here. And an important thing about today is that this is the general term for a Taylor polynomial. We need the nth derivative at c divided by n factorial times x minus c to the n. And we've given this a definition. This is a Taylor polynomial. If the center is at 0, it's got a special name called a Maclaurin polynomial. So we learned all this yesterday, and later on we're going to use Taylor polynomials to approximate functions. And this next theorem is something we're going to talk about later, not today, but the theorem says that if you stop a Taylor polynomial at some point, then you're leaving off a lot of terms, and that term we're going to call as a remainder. And so we're going to come back to that. And so anyway, I want you guys to see that if we stop a Taylor polynomial at a certain point, we're going to have an error. And we're going to be thinking about how do we describe the size of that error. Now, if it's alternating, we don't have to worry about this formula. But later on, we're going to figure out how to give a bound for an error even if it's not alternating. So just want that to be in your head. So the top part was just a review of what we learned yesterday. So let's take a look at a Taylor polynomial. I've got a second degree Taylor polynomial. I know it's a second degree because I've got an x squared. And we are supposed to look at this graph, and we're supposed to figure out the signs, plus or minus, of a, b, and c. So let's take a look at the general form for a second degree Taylor polynomial. And we are centered at x equals 0, so this is actually a Maclaurin polynomial. So the general form would be f of 0 plus f prime of 0 times x minus 0, or just x, and then plus f double prime of 0 over 2 factorial times x squared. That's a second degree Taylor polynomial. And what we have to do is figure out the signs, plus or minus, of a, b, and c. Well, a is going to equal f of 0. And then f prime of 0 is going to equal b, because that's what's in front of the x. Now, f double prime of 0 divided by 2 factorial works out to be c. So we could say that f double prime of 0 is 2 factorial times c. So let's see if we can figure out, based on this graph, if we can figure out these signs. Well, f of 0 is simply the y-intercept. So there is f of 0, which we think is a. Now, f prime of 0 is b. Now, f prime tells us what about a graph? It tells us if we are increasing or if we are decreasing. What is this graph doing over here? Well, it's increasing. Since this graph is increasing, then I think that the derivative, the first derivative, should be positive. The second derivative would tell us concavity, and this graph is not very happy about this, and this graph is a concave down graph. So let's answer the question. F of 0, which is equal to a, must be positive because this is the y-intercept and it's above the x-axis. What about f prime of 0? F prime of 0 is equal to b. And I'm going to say that that is positive because f, that's the graph of f of x is increasing. I'll put a little is here. F of x is increasing. Now what about f double prime of 0? Now that would equal 2c. And this is a concave down graph. Now, so I'm going to say that 2c is negative, which means that c is also negative. 0 divided by 2 is still negative because f of x is concave down. That's not so bad. Let's take a look at another example. I'm given a third degree Taylor polynomial, and I have to find the values of the f of 4, f prime of 4, blah, blah, blah. You can see what we need to find there. So let's write out the general term for a third degree Taylor polynomial. That would be p sub 3 of x is going to equal f of, now this is centered at 4, so I'm going to have f of 4 plus f prime of 4 times x minus 4. This is from our definition, plus f double prime of 4 over 2 factorial times x minus 4 squared, and then plus f triple prime of 4 over 3 factorial times x minus 4 cubed. So we have to find these values here. So let's just play a little matchy-matchy game. F of 4 is going to equal 2. See how we're just going to match this up? F of 4 equals 2. f prime of 4 is the coefficient of the x minus 4 to the first term. Where is my x minus 4 to the first term? Well, I don't see it. I've got an x minus 4 squared. If it's not there, then that means that the coefficient must have been 0 to knock it out. The term is gone. So f prime of 4 is 0 because there's no x minus 4 term. There is no term that has an x minus 4 to the first. Therefore, it must have been 0. Now, f double prime of 4 divided by 2 factorial is the coefficient of your x minus 4 to the second term. And we have an x minus 4 squared term. The coefficient is negative 5. So f double prime of 4 divided by 2 factorial must equal the coefficient of the x minus 4 squared term. So I'm going to put a 1 underneath this, and we have to basically solve this for f double prime of 4. So we're going to cross multiply. Man, how long have you been cross multiplying in math? I bet it's been a long time. You've done that a lot. So f double prime of 4 must equal negative 5 times 2 factorial, which is equal to negative 10. So I've got f of 4, I've got f prime of 4, and now I have f double prime of 4. Now, the third derivative at 4 divided by 3 factorial works out to be the coefficient of the x minus 4 to the third term. So let me write that out. F triple prime of 4 divided by 3 factorial equals the coefficient of the x minus 4 to the third term. And in this example, that's equal to 8. I'll put a 1 underneath that, and we're going to cross multiply. So f triple prime of 4 equals 8 times 3 factorial. And that's, we can simplify that if we want. That's not going to be too bad. 3 factorial, 3 times 2 times 1 is 6. Times that 8 is 48. So have I found them all? There's f of 4, there's f prime of 4, there's f double prime of 4, and there's f triple prime of 4. I have. All right, does f have a local maximum, a local minimum, or neither at x equals 4? Now, first of all, for either one of these to be true, f must have a critical point at 4. If f does not have a critical point at 4, we cannot have a local max or a min. Now, what that means is that f prime of 4 must be 0, or f prime of 4 must be d anything. That's not a 1, that does not exist. So, is that true for our problem? Well, yes it is. F prime of 4 equals 0 because there was no x minus 4 to the first term. Now, for a local maximum, we can go to the second derivative to figure that out. A local maximum, we're going to need to have concave down at a critical point. And a local minimum, we need concave up at a critical point. Local maximum would be f double prime negative. Local minimum would be f double prime positive. Since f prime of 4 equals 0 and f double prime of 4 worked out to be negative 10, which is less than 0, then f has a local maximum at x equals 4. That's the second derivative test. All right, last example here. The Taylor series about x equals 2 converges to f of x, the nth derivative of f. So they're giving me a formula for the nth derivative. And they've got this nth derivative at 2. And this is valid for any n greater than or equal to 1. So I can get the first derivative, the second derivative, the third derivative, the fourth derivative from this formula. And f of 2 equals 1. We're going to write the third degree Taylor polynomial for f about x equals 2. Now, from the page before that I circled, this is our general term for a Taylor polynomial. This is the nth term of a Taylor polynomial. We've got to find the nth derivative at c divided by n factorial and then times x minus c to the n. So let's write out the third degree Taylor polynomial. So p sub 3 of x centered at 2 is going to equal f of 2 plus f prime of 2 times x minus 2 plus f double prime at 2 divided by 2 factorial times x minus 2 squared plus f triple prime at 2 divided by 3 factorial times x minus 2 cubed. So we need to find f of 2, f prime of 2, f double prime of 2, then put that over 2 factorial, f triple prime of 2, then put that over 3 factorial, and we'll have our answer. So have they given us any of this information? Well, all they've given me is that f of 2 is 1. I know that 1 goes there. But they have not given me is f prime of 2, f double prime of 2, and f triple prime of 2, but they have given me a formula in order to find that. So I'm going to find those by using this formula. So f prime at 2, this is the first derivative at 2. So it's like f sub, not sub, but the first derivative of f at 2. But we just use a little tick mark until we get out to 3. We don't really start putting numbers in there like 4, 5, and 6 until after 3. So the first derivative at 2 means replace your n with 1. So that's going to be 1 plus 1 factorial over 3 to the first, which is equal to 2/3. So now I have f prime at 2. Now f double prime at 2 is going to equal, replace the n with a 2. And so that's going to be 2 plus 1 factorial over 3 squared, which is 2 plus 1 is 3 factorial over 9, which is, we can simplify this if we want. That's 6 over 9, which is also 2/3. That's okay. There's nothing that says that those derivatives can't be the same. And then the third derivative at 2 is going to equal, we'll replace the n with 3, and so that's going to be 3 plus 1 factorial over 3 cubed, which is going to equal 4 factorial over 27. And 4 factorial is 24. I could reduce 24 27ths. I'm not going to. You don't have to reduce your fractions. We're just going to plug it into the formula. So I'm going to say that my third degree Taylor polynomial is going to equal f of 2, which was given to me as 1, plus f prime of 2, which I figured out was 2/3, and then we put that in front of x minus 2, plus f double prime of 2 divided by 2 factorial. That's the coefficient of the x minus 2 squared term. F double prime of 2 is 2/3 divided by 2 factorial times x minus 2 squared. And then the third derivative at 2 divided by 3 factorial. So that's 4 factorial over 27 divided by 3 factorial times x minus 2 to the third. Now we could stop there, but this is beneficial to know. I'm going to simplify this and get rid of my compound fractions. I'm just going to drop this. If you have a fraction divided by a number, you can take the denominator and just drop it down, the denominator in the top, and drop it down with this 2 factorial. I just want you to see how this works. This is going to be 1 plus 2/3 x minus 2 plus this 3 can drop down with that 2 factorial, so I can have 2 over 3 times 2 factorial times x minus 2 squared. And the same thing with this 27, it can just drop straight down here. So that's 4 factorial over 27 times 3 factorial, that's a dot for multiplication, times x minus 2 cubed. So that's my answer, and yes, we could simplify this, but we're not going to worry about this for now. We just need to know the formula and how to write them. So I will see you guys tomorrow.